Okay, so we are looking at this equation of a function, and you want to look at what is first the parent function. So that would be the absolute value of x. All right, that's my parent function. So everything else is a transformation. All right, it's going to move or change the function. So you look at what you've got here. You've got the 1/3 in front. So that is going to be compression, right, by a factor of 1/3. All right, and so fraction, compression, they sound the same. And that's going to be the slope of my absolute value function. All right, it's going to make it a little bit flatter. And then now I've got this -4 inside. All right, and so it's going to move. It has to do with the x, right? I've got x -4. So it's actually going to move it horizontally, and it's going to move it to the right 4. Right, and the inside is the opposite of what you would think. It seems like it should go to the left, but it actually goes to the right. So +4 makes that 0 inside. So now I've got my next transformation is the +1. All right, so that +1 is going to move it up 1. All right, it's a vertical move. It's going to go up 1. And so now this right here tells me where my vertex is. My vertex is going to be, I start at the origin, right, which is where my parent function would have been at, right, 0, 0. So I start at the origin, and I'm going to go to the right 4, 1, 2, 3, 4, and I'm going to go up 1. Okay, so that is where my vertex is going to be. And then now I'm going to use this right here. This number in front is my slope. And so I'm going to go up 1 and over 3. Okay, so I'm going to go up 1 and over 3 and put a point there. Up 1, over 3 and put a point there. And that is this side. And then to the other side, I'm going to go up 1 and to the left 3 and put a point. Up 1 and to the left 3 and put a point. All right, and these are points on the left-hand side of that absolute value equation. All right, so the equation is going to be this right here. All right, it has a slope of 1/3, and the vertex moved from the origin, it moved right and up 1. That's my new vertex. Okay. So now if I look at, so now I'm going to write down what's the domain. That's my x, right? Those are all the x values of these points. Okay, well, x, it goes to the left forever, right? This function goes to the left forever, and it goes to the right forever. So my domain is -infinity to +infinity. All right, and now it says use both notations here. So that would be all real numbers for set notation. All right. I could say, write it like this. All right, that shows me it's a set. And x is an element of all the real numbers. Okay. And then the range is going to be the y values. Okay, so that's my up and down. Where is it going? Well, it starts at, and the vertex actually tells you what your range is going to be, right? My vertex here is at +4, up 1, right? Right 4, up 1. So that's where my vertex is. So this right here, that 1, that's the lowest y value that I can have. All right, so my y's start at 1 and they go up forever. Okay, because it goes to positive infinity. Both sides go to positive infinity. So my y's go to positive infinity. So my range would be, well, the lowest y value is at your vertex. That's 1. Oh, it includes 1, so I'm going to use a square bracket. So I've got a square bracket, there's 1, and it goes to positive infinity. And if I want to write that with set notation, I would say, okay, those are my y's, and y has got to be greater than or equal to 1. All right, and the next thing I can say about, this is talking about the end behavior, all right? The ends are right here, right? The ends, just like it says, okay? Well, it's going to positive infinity, and this is going to positive infinity. And both ends are going to positive infinity, all right? The y is approaching positive infinity on both ends. And one way to say left means as x approaches negative infinity, y is approaching positive infinity. And to the right, that would be as x approaches positive infinity, y is going to positive infinity. All right. So then for number 2, all right, it would be the same thing. The transformations are what I'm going to look at first if I'm going to graph this. Okay, so I would notice what I've got in front here is a negative. So that means it's going to give me a reflection over the x-axis. Okay, and then the 2, right here, that is the slope, right? So that's going to stretch it out by a factor of 2. Okay, that doubles all my y, so it gets stretched out and skinnier looking. And then the next one that I see, all right, is this x minus 1 inside, so that's going to go to the right 1. Okay. Remember, inside is always opposite. And then now my last one here is going to go, I've got a minus 5, right? A minus 5. So the minus 5 is going to go down 5. Okay? And these tell me where my vertex is. All right? I'm going to go over 1, and I'm going to go down 5. So to the right 1 and down 5. That's my vertex. All right? And since it is a reflection, right, it's going to be negative. I've got a negative slope, negative 2. So I'm going to go down 2, 1, 2, and then over 1. 1, 2, over 1. So that's that left side. Over here, I go down 2, over 1, down 2, over 1. So see how it's kind of skinnier? So that's a stretch of my factor 2. And then the reflection is why it's upside down. Okay? Now, if I want to talk about the domain, well, it's going forever to the left and forever to the right. So it's going from negative infinity to positive infinity, domain-wise. Negative infinity to positive infinity. With set notation, that remember, that is the x's, and the x's are real numbers, all real numbers. Okay, and then range-wise, if I'm looking at the range, okay, then I've got the y values. Remember, the vertex tells me the range. Okay, this vertex, this y here, this negative 5. Okay, this negative 5 here, that is my y value. So that is going to be the, actually now, since it's flipped over and reflected, that's the highest y value, all right? So that means my range goes down, right? So it's going to go from negative infinity to -5. Oh, it includes -5, right? So I've got to make that a closed bracket, right? Because it actually includes 5. And then set-wise, that would be, those are y values, and then the y's are less than or equal to the -5. Okay, and now if I'm looking at end behavior to the left, okay, these are the ends, all right, and they are both going down, right? So left, remember that is as x approaches -infinity, right? So you're going to the left. Your y values are going down. So they're going, I could say f of x, y, which means y, is approaching -infinity. And then the right side would be as x approaches +infinity. The right side is as x gets bigger. My y's, my f of x's, are getting smaller. Okay, both are going down. Both ends are going down, right? They're both negative here, right? Negative, negative, okay, because it's going down. Okay, over here, you've got positive, positive, because it's going up. Okay, that's 1 and 2. What else do we have here? So now we're graphing the inverse. All right, if I'm graphing the inverse of that function 1, what I'm going to do is I need 3 points. All right, I need the vertex, and then a point to the left and a point to the right. Okay, so let's see. Let me erase this here. See it. So our vertex is at 4, 1, 1, 2, 3, 4, up 1. So that is the vertex, is at 4, 1. Okay, so then the inverse of that would be, all right, the vertex was 4, 1, so the inverse would be, you switch them, right? So it would be 1, 4. All right, so 1 and then up 4, 1, 2, 3, 4. Okay, so that is where the vertex is going to be. That's the vertex. And then I'm going to get a point to the right and a point to the left. Okay, so this, remember this slope was 1/3, so I go up 1, 1, 2, 3. All right, so this, the vertex was at 4, 1. So this point right here is at 7, 2, right? So the inverse of that would be 2, 7. 2, 7 is the inverse. The original point on my original graph was 7, 2. All right, that was 1 to the right of the vertex. And 1 to the left of the vertex, well, I go up 1 and over 3, right? Remember the slope was 1/3. So I went this way, 1 to the left, excuse me. So that would be 1, 2. Right? That point, the coordinates of that point would be 1, 2. So the inverse would be 2, 1. So 1, 2 is my original graph. So the inverse is going to be 2, 1. Okay, and then now I'll just graph those. All right. So the inverse would be 1, 4 is my vertex. And then I've got 2, 7, 1, 2, 3, 4, 5, 6, 7. And then 2, 1, 1, 2, 1. Notice it's just sideways because we switched the x and the y axes. So it's the same v, okay, but it's opening up to the right. Instead of opening up, it is opening up to the right. All right, my original one was at 4, 1, 1, 2, 3, 4, 4, 1. All right, and then went like that, and like that. All right, so the original one opened up, and then the other one, if you flip them over, right, if you go over this line, y equals x, right, then over the line, y equals x, if you reflect over that, you get the inverse, okay? All right. So is this pink function, going back to the pink function, is that a function? Or the inverse, is the inverse, right, is the inverse a function? Okay, so let's try to get this regular. Is the inverse a function? No. All right, because the inverse, all right, these x's repeat. Okay, at the point 2, you have 2 points coming out of 2 y's for the value 2 for that x value. So it's not an inverse, it's not a function. All right. So we'll go ahead and stop right there and start a different video for the other ones. Good job.